Okay, so this time I'm going to do rotate left. We have done arithmetic shift left and logical shift right, and now we just got to do rotate left and rotate right. So rotate left, it's similar to shift left, except it basically shifts around with the carry flag, or it rotates around with the carry flag. So you shift a bit out of the carry flag and you shift it into the value, and then the bit that gets shifted out at the other end goes back into the carry flag. It is a rotation basically, but it's using the carry flag with it as well. It's not just a straight rotate with the actual byte that you're working on. So let's just start by writing the first test for that. We'll do the accumulator one to start with because that's the easy one. So I suppose let's copy. I'm just going to copy. I'll copy one of these to start with, just to get us going. Let's just take one that shifts a 1 out of the carry flag and puts it into the value. So yeah, if we start with something in the carry flag, then we start with a 0 in the. So this will shift on the accumulator. So let's just put 0 in the accumulator. And this instruction's called roll. Don't need any other parts to that instruction. It takes 2 cycles. Basically, it's going to take the value. So bit 0 is filled with the current value of the carry flag. So if we've got something in the carry flag and we shift it into here, we should finish up with 1 in the accumulator. And the carry flag should be false because bit 7 gets shifted out of the A register and put into the carry flag. So bit 7 should be false. We would expect 0 to be false because we ended up with a 1, and we expect a negative if it's negative and it's not. I think that's a reasonable test to start with. So let's just see. This is roll accumulator. Just call it roll for the accumulator one. Can shift a bit out of the carry flag. So we need to define this. And there we go, instruction not handled. So I think what I'm going to do is initially, yeah, just let's go in and implement that one straight away. Or start implementing it. So in this case, yeah, we definitely want to, can we reuse any of the code we've got for shift left? I think we can actually use this, can't we? Because arithmetic shift left is doing everything we want. It's taking the bit 7 and it's making it the new carry flag. It's doing the shift left. It's setting the -0 flags, and it's consuming a cycle. So that is actually what we want, except we need to shift in the old value before we do it as well. So we can just take that to start with, and we can put that in. Now that doesn't do everything we want, but it does a lot of the things we want. So yeah, so we didn't get the correct value in the A register because we're not taking the value out of the carry and putting it into there. Oh yeah, and the 0 flag's wrong because we've got the wrong value in as well. So that's fine. So what we want to do then is just store the carry flag. I want to store the carry flag just before we, let's just call this bit 1. Store the carry flag before we do the shift left, and then afterwards we make, we want to set that bit into the value that we finished up with. It's just like I want to do that, but I don't think that's going to do what I want. Don't think it will anyway. Let's just see what that does. Unsafe mix of types. Yeah, that's what I expected. So what's the best way to get, because basically what I want is I want this bit 1 to be a value like, so I want it like that if it's actually if it was actually set. I mean, I can do it like this. Is that going to pass? Yes, it did, but this doesn't work because we are. So I am setting the. I am moving the bit in now, but this function doesn't quite do what we want because it's setting the 0 negative flags, and I haven't set the result. So this function can't do what I want, which is unfortunate. So let's copy this out. And let's make a new version of this. Let's put this in here. So that's the A register. And we're going to refactor this out again later on, but it's just so we get it like the way we want it. So this wants to go in here. And need to save the bit that we're going to take out the carry flag, set the new carry flag to the contents of the old bit 7, do the shift left, and then put the bit that I saved back into the A register, set the 0 negative flags, and then decrement a cycle for it. I think that's what I wanted. Let's try that. 0 flag is wrong. Why is the 0 flag wrong? Was it expecting? Expected false. No, we didn't. 0 flag should be. Yeah, 0 flag should be false. Is that right? 0 flag set if A equals 0. What have I done wrong? Oh, because this is the A register now, and that's the A register. Whoops. So this is all working on the A register at the moment. Let's try that. Okay, that's better. So I've basically got a version of rotate left that works in this one particular case, and it's not been refactored or anything like that. So that seems to be exactly what I want. Let's add a few more tests for that and make sure that's working the way we want. Let's do something that will shift into the carry flag. I can shift a bit into the carry flag. There we go. So let's start with the carry flag on false. We'll start with something that will shift a bit into, yeah, so this negative bit is set. So yeah, so that bit there will get shifted into the carry at the end. So we'll expect the carry to be true. And we will expect the 0 to be true as well, because we're going to end up at 0 because we shift that bit out. And we expect negative to be false. Yeah, that's right. So this can shift a bit, yeah, into the carry flag. So let's try that and make sure that works. And it does. So is there any other good tests I can do for this? I mean, we can test that both those two things happen at the same time. Because the carry flag, well, the carry flag started at false and it ended up at true. So we knew that we changed it on that one. Wondering if there's any other good test that we can do. We'll just do maybe one more test that just takes some random value or something. I suppose one of the tests that we can do can shift 0 with no carry. There we go. So this would be a total 0 shift. So we start with nothing in the carry flag, we have 0, we finish with 0, and the carry flag is still 0 at the end. 0 flag will be true, negative will be false. Start with that. Oh, I need to start with that on false, and it should finish on false. That should work because there should just be 0 in there. it does. And is there anything else that I should do one that finishes with a 0? Can shift a value that results in a negative value. So I'm doing a bit more test than I did with shift left, but I suppose this one's a little bit more complicated. We can do something that's just got this bit set here. Yeah, something that's just got that bit set there, because that'll get shifted over into the carry. Let's just set a few of these other bits as well. Let's do 1 1. There we go, let's just do that. And let's start with the carry flag, why not? So what we expect at the end is everything's shifted over. Ooh, so that 0 pops out, and you would shift a 0 in at the end, but we've got a carry, so we actually shift a 1 in at the end, so we'd expect that value. Now in this case the carry flag is going to be set false because we didn't carry flag set to the old bit 7. Yeah, there was nothing in there. 0 flag is definitely false because that is not 0, but the negative flag in this case is true. So let's just see if that works. And it does. So I'm pretty happy that works. That's the accumulator version of it done. So I wonder if we can, let me just put a little note there. This is all roll. Roll. So yeah, so that's not bad, but obviously like before, we can't really use this the way it is. We're going to need to refactor this. So let's do the 0 page version of this as well. Then we'll see what we need to refactor out to make that work. So let's just take one of these tests. Oh. 0 page. So this is the 0 page version of the same test. So in this case, it will affect the next value in memory has the address of the value that we want to change in the 0 page, and then we'll put that value actually in the 0 page. So in this case we're going to put 0 in there instead of in the A register, and that's the value we want to test at the end. So let's roll 0 page. So let's go define that. Instruction not handled. So now oops, you can go and implement that one. So we need to do reading the 0 page and read the operand. In fact, we'll take all this for now because it's very similar. We do all that and we read the operand and then we write the result back in. Now the actual thing that we want to do is this here, isn't it? So this is where we now need to factor this out. So rather than passing in the A register, we will actually make this into a function. I think let's call that new bit 1. Yeah, let's do that. Let's go up here and we'll do another lambda. So let's take the version of that. This is roll. And we don't want to operate on the A register anymore, we want to operate on this operand, I believe. Operand. Yeah, I think that's it. We want to return the operand that we just changed. Right, I think. Let's see if we can replace that with what we've got down here. So this is going to do this, but it's going to do it with the A register and set it back into the A register. So that doesn't change. And for now, let's just write this operand back in here, just so we get this, make sure this still works. And we've only got one failed test. Yeah, and it's the 0 page one. So it looks like that still works. So in effect, what we can do now is do that. I mean, I suppose it'd be easier if we just pass this in by reference, maybe, then we wouldn't have to bother returning it. Is that a better way of doing this? I'll tell you what, I'll keep it the other way. I think it's a bit more explicit doing it the other way. I think I prefer it like that. I could pass it in by reference and just have it change it, but in this case, I'll do it like this. I'll do it the same way I did the other ones. Maybe it's a little bit more debuggable if I ever have to debug it, because I can see these values on the stack. Right, I actually think that's going to make that pass. Oh, it doesn't. Oh, because it's 5 cycles. It is actually a 5 cycle function. I've probably said it wrong in the test. And it's actually 5 cycles. So it's actually telling us that it's taken 5, and that's what I expected it to be. Just got the test wrong. So that works. So I just need to make 0 page versions of these. Is that right? Yeah. I'm going to make 0 page versions of these. So let's do that. Right, is that that? Yes, it is. So that is rotate left, accumulator and 0 page versions working. So I'm going to do the same thing I did last time, and I'm just going to go to warp speed to do the other 3, because they're going to be exactly the same thing I've just done twice already there, which is take these 4 tests and do a version that has the different addressing mode, and then write the code that makes those pass, which is going to be almost identical to this code here. So I'll just warp speed the rest, and then we'll see what we've got at the end. Right, so I think that's it. That is rotate left. Again, there wasn't that many addressing modes for that one. One of them was quite simple because it was just the accumulator one. Next time I'll do rotate right, and then we haven't really got hardly any left at all. I think it's only a couple of instructions. So that's looking really good. And there wasn't much code for this one. It wasn't a very difficult one again. It was basically just this, which is very similar to these two, except it's got this shifting the flag out. So yeah, in the next one, we'll do rotate right, and then we'll see where we get to.